All right, so yesterday we started with the fundamentals of object-oriented programming. So we looked at the 4 pillars of object-oriented programming. We also looked at what they mean. We went through a few examples. So let me just share my screen. Just give me a minute. All right. Okay, so even as we begin, can anyone remember the guys who joined yesterday's session? Can anyone remember the 4 pillars that we discussed yesterday? The 4 object-oriented programming pillars. If you've worked with any other language, they're still the same, because object-oriented programming is paradigm, so it's not unique to JavaScript. So if you've interacted with any other programming language, you've probably come across it, especially languages that are more oriented to OOP. Davis abstraction. Abstraction is one of them. So you can either just unmute or just type in the chat. So yes. Nelson. So Davis, yes, abstraction is one of them. Nelson.
So there's polymorphism, encapsulation, and inheritance.
Okay. So Davis said abstraction, true. And then we have polymorphism. We have encapsulation, and then we have abstraction. So let's just do a small recap before we proceed, because today we look at this keyword, which we touched on it yesterday, just a bit, and then we will also look at prototypes. Okay, so let's begin. Let me share my screen, then we can go through what we did yesterday. Am I audible, by the way? Can everyone hear me properly?
Yes, no scare.
Okay. So let me share my screen. Okay. Okay, can you see my screen? Ndio inakam, I think ndio inakuja. All right, I'll assume everyone can see my screen so that now I can begin. Okay. Let me split my screen into 2. Zoom in a bit. I'll close this terminal. Then I will open up the README file we used yesterday. So I'll just do a brief recap and then we'll proceed. So let me just close this up. Open this. Right, so we went through the 4 pillars. So Nelson has mentioned encapsulation, polymorphism, and encapsulation. So and then Davis mentioned abstraction. So we looked at a few examples already yesterday. Declaring objects using the object literal syntax, which is basically when you want to define an object, you just use the curly brackets. And then whatever comes inside of the curly brackets are the properties for your objects and the values, so key value pairs. Then we proceeded to talking about the 4 pillars. So encapsulation, we went through encapsulation. We talked about what it is, how to use it, and we had an example of how to encapsulate information, for example, in the bill information object. Initially, we had it separate. So the way we were doing it initially was this right here, procedural programming, where your information is separate from your functionality. So you have not quantified, you have not put all your created logic into one object. And then, so now we highlighted how encapsulation actually works by now putting everything into one container, which was this. We talked about abstraction, right? How you don't need to know how a particular thing works for you to use it. Like for example, anytime you use the string method .to uppercase in JavaScript, you don't need to know how the to uppercase method works internally. You just need to know that it exists. So that is what we mean by abstraction. Inheritance, how you can pass down properties. For example, the to uppercase method is present in the string object that comes with your JavaScript. So there is a global object called string that is available to you as the developer. So the to uppercase method is passed down to every data type that inherits from the string object. So anytime you declare a string, you always get the dot to uppercase method available to you. You don't have to write it on your own. Same with number types, same with Boolean types. You always inherit those methods and properties from the parent object. Then we talked about polymorphism and how you can use, for example, we used an example, we had a class called animal, and the animal class was declaring a method within it called speak. And then we looked at how you can change whatever speak returns based on your class. So when you define a different class that extends animal, so basically we are borrowing some functionality from the animal class, and then we can define our own implementation of speak within it. So that is polymorphism. We have two methods that have the same name, but they're doing different things. So basically the speak within cat is simply overriding the initial animal, the initial speak in the animal class. So that's just a brief recap of what we did. So now today we are going to now cover this keyword, as well as prototypes. If we have time, I think we should have time. If not, then we'll just proceed tomorrow as well. We'll just do some of it tomorrow because this topic can be very confusing, and I want us to go step by step. Okay. All right, so let's start with this README document. Okay, let me start my app. Again, this is a very simple HTML document. We just have a simple HTML document with the script tag and the title. So there's nothing here other than that. The only reason I have this HTML file is because I need to see what I'm logging in the console. I could use Node.js, but I feel like that would just confuse a lot of people. So because we are doing the web track, we just use the browser. So let me open this up. Okay, here it is. Let me just close this one. And then you can just comment out most of this code. Anything that we will not be using, just delete everything actually. Let's make sure it's working. We are actually linking to our code. Let's open the console. Yes, so our script tag is attached to our HTML file. Right, so now let's go through the README file. Okay, so we briefly touched on this keyword yesterday, very briefly. So now today, let's take a deeper dive into it. So anytime we call this keyword in the global scope, anytime we call it without anything on, for example, on the left side, right? What it does, it assigns this value to the window object. Remember, your whole application, your whole JS file is wrapped around a window object. So for example, when you do something like an alert function, I also showcased it yesterday. Anytime you have an alert function, right, and you say something like hello, something like hello. Okay, let's refresh the page. You can see it's logging out hello. But what it's actually doing, right? Because we know we have a window object, what it's doing is it's pre-appending this alert with a window here. Because this alert function exists as a property, as a method on the window object. So if you just press OK and we refresh the page again, you can still see we are getting the hello, even though we've pre-appended it with the window.alert. It's not complaining because it's still valid JS. So anytime you run like a global function or a global property, it's getting it from the window object. So the way you should think about it is we have a big window object that has the alert function defined within it. So if we just come down here and I just remove this, right? And I simply say this, just like that, without anything else. Now, this is referring to the window object. That's what it's doing. If I now console log this, I console log this in the console, right? It will give me the window object. Control Shift I. Sorry, I was pressing the wrong thing. So you can see we first get hello, which is this first line, and then we get the window object. Now, if you open up, you can see all the functions, all the properties that are available to us through the window object. And you can see the first one is the alert method right here. The F means it's a function. So this is where it gets it from, because we did not define our own alert function, did we? We didn't write it anywhere in the code. It comes as an API in your browser. So anytime you log out this without anything else, it simply logs out the window object. Okay, so now how do we set the value of this? So let's go through the documentation. So the value of this depends on where and how, depends on how and where we call. Sorry, there's a mistake here. It depends on how and where we call that particular this. So if we call this on the global scope, it simply means that this is going to be assigned to the window object because there's nothing else. Okay, but now when you do it inside of a function, this changes, the value of this changes. So this doesn't mean that we are talking about necessarily this particular object, the one here in Planet. Right? If you were to call this, what is this? Someone has a question. Does someone have a question? I thought I had someone raising their hand. Okay. So I'll go.
It is a message. It is a message on the chat box. So I think they are trying to say that how about if you check the type of these, like the way you do type of something.
Okay. So type of this.
Yeah.
Okay. All right. So that's Ian. Okay. Why do we want to check the type of this? Maybe that's what we can, but why do we want to do that? Type of this. It's an object. So that also like confirms what I was telling you. So there's a window object that traps your hole anytime you run your application. And you, for example, define properties like outside, like something that you did not write yourself. It comes from the window object. So you can see it is an object when I log out type of this. So type of this is a function, right, that you can use now to check types. We have different data types. We have string values, we have numbers, we have Boolean values. So it's telling us that this is an object. Okay, if you simply remove this, then you get that object. Okay, so let's proceed. So now let's talk about this. Okay, now we've said that the value of this is set depending on how you call it. It's not always the same thing. So I will define two functions, two exact functions. So I'll just, first of all, comment these two lines of code. And then I will define a function called what is this. Say to a function, and then I will simply return this. Okay. Now, before I even console log the value, who has an idea what the value of what is this will be? What is this? What will be logged out in the console? If I say CL, actually I will not do that. I'll simply come here, say what is this, and call it that. So who knows what the value of this is in this particular instance? What if I was to say console log right here? If I was to log out the return value of this function, what would be the value of this? Can anyone take can anyone try?
We saw that yesterday, wasn't it? The window object.
Okay, why is it the window object? Because it is the window object. I agree. Okay, sir. So why do you think the value is the window object?
The function is a property to the window option.
And then remember what we said about the value of this, how it gets assigned. It depends on where you call it. And if you look at our implementation, we are calling what is this on the global scope. It's on the global scope. So whatever is to the left of this, what is this, is the window object. So you are right. If I console log this value, do a console log of this value, we'll get the window object. But that's because of how we call it. Can you see how we did it? There's nothing to the left of what is this. There is the window object, which is now wrapping around your whole application. So that's why when you log this right here, we are getting this value. We are getting the window object. Now let's change that implementation. So now let's do this. Let's create a function, right? What is okay? This is now an object. Okay, and then we can have like this prop one. This is prop one. Then now here we want to set another property, and the value of this property that we want to set, we want it to be this. What is this function? So what is this? Then we want to set this equal to what is this? So this is a property. We'll just call it func property. Func prop. This is a function property because it points to a function. And the function you are pointing to is the one that we defined up here, which is this, what is this function? Okay, so now if I wanted to access this func property right here, if I was to do what is this, right? So now I want to get this object. Okay, let me just give it the full name so that we don't get confused. So I'm calling first of all this particular method. So if I just console log it, and see the object is being displayed in the console. Right here, we have a prop one, which is this is prop one, and we have a func prop, which is a function, hence the F. So if I wanted to access this property, right, that says this is prop one, I would simply come here and say dot prop one. That would give us this is prop one. So this value, this string value. Okay, so now if I wanted to call this function, because if I come down here right now and I just say func prop, will give me the definition of that function. Itanipatia kila kitu. So the F, the name of the function, parentheses, the body of the function. but we want to call it. So if you want to call it, right, we simply have to have the parentheses. So now let me delete this because I don't want to show the response just yet. Then we call it. Okay, so now with that implementation, let me put the initial implementation here. What is this? Comment, this is calling on global scope. The global scope simply means anything that is not in a function. That is what it simply means. So like this one, this particular thing, we're just calling it on the global scope. It's not within another function or anything. So now this example that we have right here, what is the value of this now? Because we have not changed the implementation of the actual function, we are still returning this. We did not tell this function to point to a different value. We just changed the implementation very slightly. We just put that value inside of an object. So now what is going to be the value of this when we now log this value here? Anyone give it a try? Anybody? Remember what we said about checking what is on the left side of your dot.
Can I give it a try?
Mm-hmm.
So I'm betting it will return the what is this object?
Mm-hmm. Why do you think that?
Well, basically because this keyword returns the object, and the object is usually on the left, and what is this is what is on the left. So that's what I'm betting on.
Okay, so let's see whether you are correct. Yes. So it's returning the object now. What is this object? Because remember, depending on how you call it, when we did it this way, you can see there's nothing to the left of what is this. Hakuna kitu hapa mwisho. There's no dot and then something. So the value of this is set when you call the function, not when you define it. When you define it, it doesn't have a value. It's only set when you now call the function. So like here, our example here, right? The value of this is set when you call the func prop. And then it's set to whatever is on the left side. What is on the left side? It is what is this object. That's why it's returning that particular object. It might look a bit confusing, it might seem a bit confusing, but I think if we do enough practice, it should make sense. So Wekesa, you are correct. Any questions, anything I need to clarify, I am more than willing to go through this again and again and again, because you will encounter this thing over and over and over again.
Yeah, so I have
Go
a
ahead.
questions. Func prop is a key.
Yes, func prop is
Okay,
a
and then
key.
you're calling it like a function.
Yes, because it's set, the value of func prop is set to a function.
Okay, so it behaves like a function.
Exactly. So we need to use the parentheses to invoke it.
Okay.
Mm-hmm.
That was confusing. It was a little bit confusing.
Okay, but is it making sense now?
Yes. So if I set it to like, if the key, if I set the value to a function, I can call the key like a function.
Yes.
Okay.
Yes. So what I basically did is, it's like just defining this function. What is this here? Just having the declaration here. But because we know we already have that function, I just reused it because we know we have it as a variable.
Okay.
I just reuse it. So it's the same as coming here and just saying you have a function here. Same thing.
Okay, I get it now. Thank you.
Okay. Someone else has a question? Just go ahead and ask.
Yes. So, is it possible to now use this function in this class we use it in a real life example. I feel like that would provide better clarity.
All
Yeah.
right. Did you have anything in mind? Okay, so let's actually write an actual object. Okay, let's define an actual object. Even use whatever we used yesterday. So let's just comment out. Before I proceed, like anyone else with a question before I proceed, but I'll basically just do the same thing again. Okay, so let's create an object. Let's call this object human. Humans obviously have first names. Here, first name. And we can have, say, hello. You can set that to a function. That. And then we can simply come down here and say we want this function to return hello, and then we can use string interpolation because I want to use the properties within the human object, right? So I want to say hello, and then we want to say this dot first name, and then we want to say this dot last. So basically what we are doing is we have an object called human that has a first name, it's supposed to be first name, a first name property, and a last name property. The first name property has a Jake value, the last name property has a Smith value, and then the say hello property is assigned to a function. Okay, so I would have done the same thing. I could have declared a function outside of the object and then simply assigned it that value. For purposes of now seeing both ways, like how you define a function outside and then give it the value of a property, I've done it this way. So now let's now log out that object in our console. There we go. We have first name, we have last name, and then we have say hello. So if I come down here and I say dot first name, we'll get Jake. If I come down here and say first name, we'll get Smith. If I come and say hello, get the function because we have not invoked it. For us to actually be able to get the return value, the hello and then first name and then last name, we now invoke it. Hello, Jake Smith. So now the reason this is working, so this now, this that we've put here, this keyword. If you look at how we called the function, how did we do it? We have a human object to the left side. If I was to do this, for example, if I was to remove this get say hello is not defined. And that is because say hello exists within that human object. We can't call it if it's not. So let me just give another example. I can just have, I can actually implement this outside because I think that will be able to show us a bit better. If I remove this here, in it here, const saying hello is equal to that function like that. And then I come here and I give it that value right here saying hello. So I've simply removed that declaration and I've now put it outside. So that now I can call it Harper from this particular implementation. And that's because I want to see the value of say hello, saying hello. So I need to change this. And I call it outside of the object. You can see when you call it outside of the object, because that's what I've done here. I don't have an object to the left side. So what it's doing, it's putting the window object before the saying hello. So we get undefined because we don't have a value on the global scope that is a first name. That is what it's doing. It's now assigned this to the window object. So it's looking for window dot first name. That's what it's looking for. But we don't have that value in our global scope. So it's returning hi undefined undefined. But now, if you come down here and you do the same thing, but now you call it within the human object, say hello, get hello Jack Smith, because the value, this has been set to the object. So now we have a reference to the first name and the last name. Makes sense? Is that like a better example? Ama, do I go over it again? Catherine, is that a bit clearer?
Yeah, that's actually clarified. Thank you.
Okay. Anyone else? Anyone else with a question?
Hey, Ian.
Hi.
I just remembered something about this thing, like this keyword. Like it's pretty confusing when you're using strict mode in JavaScript. I think this behaves like differently, right?
Yes, it does.
And then like
Yeah.
when you're using like an arrow function over
Yes.
like this other like type of function, it will also behave differently.
Yes, it will. It will. It will behave differently when you put, for example, use strict, because use strict will not allow you to access the window, if I'm not wrong. So I think for before we even get to those ones, we will first of all do the basics, and then we'll get to like use strict and arrow functions. That's why you can see I have not defined an arrow function. It was very intentional.
Okay, so it was deliberate. Okay.
It was deliberate.
Yeah.
Yeah.
Looking forward to that other section then.
Okay. Anyone else? A comment or anything you want to add or to ask? Okay. All right. So let's proceed. I hope that's clear. So this value is not set at this point. We are not defining it when we declare the function, when you're actually writing it out. This is set when you call it, depending on when you call it. That is when that value is going to be set, not before. There's normally a misconception that like this is being set at this point at the function declaration level, but it's not being declared, it's not being defined here. The value is not being set at this point. It's being set at this point, either when you call it like this or when you call it like this. Okay. All right, so Albert, do you have anything to add?
No. I have nothing to add. I'm just looking forward to when we do a real application, something like a to-do app using these OOP, because personally I've just been doing functional. I know these concepts, but I haven't used in a real application something. So I'm looking forward to when we get there.
Okay, we'll get there very soon. Okay. What else is here? All right, let's proceed, and then like we'll have questions after or comments. And then like I'm pretty sure some people have also written code in other languages. Nelson, you do Ruby, right? Are you seeing some familiarity in terms of behavior or syntax wise? Because I know you do Ruby.
Yeah, actually, yes. So like for Ruby, basically this keyword is just the similar as to the self keyword in Ruby, similar to, I guess, Python.
Yeah.
Yeah.
Okay.
So they're just similar.
Yeah, they're similar. What about like the behavior of this in terms of how we define, how we assign the value?
How we assign the value?
Yeah, like for example, say hello on the global scope, this is different from human.say hello. You have like those concepts in Ruby.
Yeah, but just only a small difference on how to access those. Let's say the key for the say hello, like on line 30, for Ruby, when you're trying to access something from an object, you cannot use the dot notation, but you use the square brackets here.
Okay.
Yeah, but they're just similar.
Okay.
Yeah.
All right. Okay. So now, because we've gone through that, I think most of us now have an understanding of what this is and when it is set, because you will encounter it multiple times. So it's good that you have like a basic foundation of what it actually does. When you're confused. So I think now with that in mind, we can now proceed. We've already done a few questions as well. So now what we will do, we will talk about constructors and what they are. So let's go through that. So what we've been doing up to this point, every time we want to define a new object, use this notation, the object literal notation, which now has the curly braces. Okay, and then we have our key value. We have our key value pairs. Okay. Had not seen the chat. Okay, Saint Onayona. Okay, all right, Fred, I've seen your comment. So let's proceed. So now constructors. We want to try to explain constructors because they are another thing that confuses a lot of people. But we want to try and break them down to something that everybody can understand. So let me just come down here. I'll explain why we need them, why they're important, because that's another thing. If you don't know why you're using it, it's very difficult to even remember how to use it. So I will do an example. Let's say now, right? Let me comment this out. This code, I'll just remove it. Let's comment it out, and so that when I upload the code to GitHub, you can still follow along. Is anything else? Okay. So I can just move this up here. So now let's talk about constructors. Okay, now anytime up to this point, the way we've been defining objects is using object literal notation. What that means is anytime you want to create a new object, you have to define it, even if that object is very similar to another object in your code. So for example, a planet, right? The planets in the solar system. Okay, so let's say we want to define Jupiter. So Jupiter, and then is equal to an object. You know that Jupiter has properties. So for example, terrestrial, we can set this to a Boolean value. And then we have CS, that is equals to false. And then we have the name to Jupiter. So this is actually false. This is actually true because Jupiter is a gaseous planet, terrestrial planet. Okay. So now we have defined a Jupiter object. Again, we can simply log that value in the console. Jupiter. We will get that object. But we have another 8, is it 8 or 9 planets that we also need to define. So using this object literal notation, what you would need to do is every time you want to define a new one, const earth, this is what you would need to do. And then you would simply have the same properties, right? And then now you change the name value. And you change these two values. This is false. This is true. Now you can imagine that after a while, this is going to become very repetitive. Kwa sababu, you're going to keep defining the same properties, but changing just the values. So you can see hapa already kuna redundancy. unajirudia already. There's some level of you're doing the same thing over and over again. Your code is repeating itself. Okay, so the way to fix that is using constructors. So from the name, what a constructor does is it constructs objects for you. It's a way to come up with objects. That's what they do. So we already have a few. We can define our own constructor, but we also have built-in constructors. So first of all, let's look at how to define our own constructors. So a constructor is simply a function that creates objects. Okay, so first of all, you know it's a function. So let's say function. Okay, and then a convention when you're writing your own constructors is they start with capital letters. So we need to give it a name, but the first name needs to be capital. Because when someone is reading your code, they need to be able to tell, okay, this function that is starting with a capital letter is probably a constructor. So we know that this constructor is going to be constructing planet objects. So we can call it planet. Like that. Then we can now have the body of the function like that. Okay. Now, based off of what we've done, the two examples we have here, we can see a planet needs a terrestrial property, a planet needs a gaseous property, and it also needs a name property. So we can define those right here. This dot name is equal to Earth, right? So then we can have this dot terrestrial equals to, so this is a Boolean value. So we can say true. And this dot gaseous equals to false. Okay, so now with that function, the only job it has is to create that object. That is what it does. So now back to this will come up again, this keyword again, it will come up again. Now, when you want to instantiate that planet constructor, when you want to now use it, so first of all, you need to define, give it a variable name. We want to have an Earth, call it Earth2. Okay, and then we need to set it. So anytime you're using a constructor, you need to use the new keyword. So now what this has done, it has gone ahead and created an object for us that has the property name, terrestrial, and gaseous. That's what it has done. If I now come down here and I say console log Earth2, let me just say first of all Earth2, you can see we have that object. You can see it's being pre-appended by the planet constructor right here. We have the name property, Earth, we have the terrestrial property, true, we have the gaseous property, false. But now, what if I wanted to create another planet? Okay, I now want Mercury, for example, const new planet. Okay, now if I come down here in the console log Mercury, you'll see, right? They have the exact same properties, but that cannot be right, because Mercury obviously should have a different name. It should have a different terrestrial property. It should have a different gaseous property. But what we did, if you look at our implementation, we had coded the values. We told it, when you define that planet object, make sure that the name property on that planet is Earth. Make sure the terrestrial property on that object is true. Make sure the gaseous property on that planet object is false. So it doesn't matter if you use a different variable name. As long as you're using the planet constructor, it will always construct the same object with the same key value pairs. So how do you fix that? Your planet function should now take in arguments. For example, a name property. For example, the gaseous, and the last one is terrestrial. And then now, instead of hard coding the values, simply pass them in. I want you to have the name property instead. I want you to have terrestrial property instead. I want you to have the gaseous property instead. So now you can see when we log in, we are getting undefined. For everything, the name is undefined, the terrestrial is undefined, the gaseous property is undefined. How do you fix it? Anytime you call your constructor, now pass in the values. Pass in the arguments now. So we know Earth, we want it to have the name Earth, right? We know for the gaseous property, we want it to be false. We want the terrestrial property to be true. Voila, we have the Earth with the name Earth, terrestrial true, and gaseous false. Same thing with the Mercury. When we want to now define the properties, we just pass them in. So the first one is the name, which is Mercury, right? You know, for gases, it's also false, and it's true for the terrestrial property. So for clarity, let me put these things in order, the way we are calling them. Yes, and then I will have the last value as. Now we simply need to change here. So the second one is terrestrial. So we have true. This one is false. And in here, true, and then false. So there are our two objects. Both of them have used the planet constructor to construct the objects. Someone has a question? Go ahead. Anyone with a question? I thought I had someone. Okay, but I had someone raising their hand. Okay. So we've used the planet constructor to create two objects that have different values, same properties but different values. So you can see now it's made our work very easy. We don't need to keep defining them this way all the time. All the other planets, we can simply pass them as arguments to the planet constructor. Anyone with a question? Something I need to clarify? Is it making sense?
Yes.
Can't you come up again? Come up again on
Is
the concept.
So I go through it again.
Yeah, sure.
Okay. All right. So let's define another one. So we know that we have a planet constructor here. Okay. So now let's think about something else. People, a person, we can have a person constructor because people have the same properties, right? I have a name, you guys have names, right? You have age properties, all these things that we all share. So that's a prime candidate for a constructor function. So let's do that. So function human, let's just say person, right? Something like that. Now, remember, convention, use a capital P. When you know you're defining a constructor function, capitalize the first letter. Okay, now, so let's go through it. We know for a fact we don't want everybody to have the same name, right? We don't want to set this.name equal to Ian. This means we are hard coding that value. So it doesn't matter what you pass into the person function. The name property will always be Ian, which is obviously the wrong implementation. So how do you do it? You simply give it these values here. Are coming down from the arguments that are being passed down to your function. So let's actually just use first name instead. I think that's more. Name, so we know we want a first name property. We also want a last name property, right? We can also have an occupation property. But then when you now call it, you can say this dot last name is equals to last name. So this is going to be set to this that is being passed down. This first name is going to be set to this, and then this dot occupation is going to be set to occupation, like that. So we've defined our constructor function that is going to construct objects. Next step. Now, if we now want to use it, same process. Okay. From here, let's comment this out. Let's come down here. So we know we have our constructor. So I now want to create an object using that constructor. So const Jake is equal to new person. Sorry. Person. We know that new person takes in a first name, a last name, and an occupation. Give it a value. The first name is Jake Smith. Okay. So we have successfully created an object using the person constructor. So now if we come down here, the console log Jake, okay, you will see now the person constructor was used to create this object. If I comment out this one, you'll see the constructor is different. This one has a planet constructor, this one has a person constructor. They have different properties. So the Mercury is coming from planet, and planet takes in the name, the terrestrial and the gaseous properties. But person takes in first name, last name, and occupation. Okay, so if I wanted to access the values, again, same process, dot name, I would get the name property. Dot last name, would be the last name property. Is it making sense? Is it sinking in? Is the why behind constructors making sense? Why we need them?
Yes.
Okay. All right. Anybody with a question?
Question, Ian. As you explain in a flow, but now in like real life, maybe development, how, do you have maybe like a specific example in terms of like maybe in web dev whereby now this one can be used just to link up now the information and maybe something practical per se?
Yeah, that makes sense. That's always most of the time you nakuanga shida. So we'll do a project on Thursday that will use OOP. We'll just use OOP only. We will come up with a book list, and we will only use object oriented. So tutaifanya tu hivi exactly. So don't worry, we will do that. Okay. Someone else. Catherine.
So maybe an example of a real life application. You can confirm, like the way you said, a book list, or in applications that require constant updating. So is it like a clean coding practice where, yes, you write your functions, but then again, you use constructors so that you're able to change your data without having to change your whole code base? Is that one application?
It is. So the repetition thing is what you're trying to avoid. Think about any system, okay? So when you log into any system, Facebook, WhatsApp, Twitter, whatever it is, normally there's information they ask you for all those platforms. Email address or email address, password, username, all those things. Now, those things, think for example, like a form. You have a username, right? Or you have a first name, last name, and a password, right? Those three things are similar to everybody. Everybody that logs into an application will need those three things, right? So that's a prime candidate for using a constructor, because now it means anytime you have a new person joining your platform, right? Anytime they submit the information into the database, you can structure it that way and then store it in the database as that particular object. So it's anytime you see anything that is repeating itself, you will find an instance where you can now use a constructor. It might seem like it's a bit there's no use cases for it, but we will go through like a proper example whereby we build something from scratch, like a library, a book list. Because even a library, books have they have titles, they have authors, they have number of pages. Prime candidate for having a constructor, a book constructor. So anytime someone comes to the library, takes a book, then you can simply look through, for example, the database, look for a book that has a particular author or a particular name, and then remove it from the database. So that's like just like a high level example that I thought about. I don't know whether it's making sense, but to Catherine's point, that is exactly what happens.
So in the case of the example that you've given, for let's say someone is trying to log in and certain structures are still the same, so would they now use an API and then add a function that simply calls specific sections of the API whenever a user tries to log in? And then now they would add that function within this constructor. I don't know if it's making sense.
It is like, and then like think about it this way. So every person can speak, or most people can. It's like something that most people can do. So you can put that in the person constructor because the assumption is most people can do it, right? So that's also something else. So like, for example, having 2 eyes, anything that is similar, like kwa kila mtu, you can just put it there. So then now if you want to use things like functions, you can do the same thing. It doesn't just have to be properties. You can now have like this.speak. Then you can set that to a function. And then now you can return something back. So we can say return, let's use string interpolation. We can say, so we can use first name, last name. This dot first name, this dot last name. So now let's go and check our person constructor. Let me just log out. Let me just remove this and just log check, just check. And see, we have same thing, same property, key value pairs. And then the speak property, right? It's a function. And the function is borrowing from the initial fields, the initial properties. So this dot first name and this dot last name. We're simply returning, for example, Jake Smith is speaking, because these values right here, this is going to be replaced with whatever is passed down here. And then last name is going to be replaced by Smith, and then is speaking. That's it. Now, if we call that function, okay, we are getting undefined. That is because it is this dot name. So supposed to be first name. There we go. Jake Smith is speaking. Making sense? Any questions? Is there anything I need to clarify?
Hey, Ian, I'm curious about something. Do these like constructor functions behaves the same way as like regular functions? For example, does it take like a default? Can you use like a default parameter on
Yes, they do.
constructor functions?
They do.
Yeah, you can.
They work you can. They work exactly the same. Hakuna tofauti.
Okay.
Yeah.
So, for example, something like legs, like everybody has 2 legs, like at least 2 legs, for example. So, if you have like an argument for legs up there, not inside the function, the constructor function itself, not that method.
Yeah, you meant here.
You meant there, yeah. You know, you add default parameters for a function. Legs
yes, just
is equals to 2, and then you don't define legs. Will that work? Because you've already assigned something to it.
Let's do that and see. You
We
mean
could just
now
say
if I come
this dot legs is equals to legs, but now when you're constructing the object, you don't pass in legs. Will it take the default parameter that you specified in the constructor itself?
Okay,
Like
I see
how
what you
ordinary
mean.
functions work. Yeah.
Okay,
I was
I
curious
see what
about
you
that.
mean. Okay, so let's just try and see. So we can come here and just log out.
You still have to do the this dot thing for the legs, but now when you construct it, you don't pass in the values for the legs. Will that work? Like you only pass it in when you want to overwrite the default one. You get?
Okay. Yeah, I get. So we don't pass it in. So the exact implementation we have basically.
Yeah. So for example, for this Jake, we are not passing in. Yeah. So we have legs too, like the way the normal functions are.
Let's see. So you do have legs right here. Okay, you can see it. It's logging 2.
Okay.
Yeah, so it's working. It works exactly like a normal function.
Okay. That's not good to see. Oh, another feedback on how they're asking, like, where will you use these things? A good example of where you'll use it is when you're handling interviews, like data structures and algorithms. Maybe when you want to create like a linked list or something, the easiest way to implement it will be using like OOP. So yeah, it's a pretty important topic in JS, and it has many like applications. A key one is that when you're doing interviews, like the functional approach equivalent to solving a certain question versus the OOP way, you'll find the OOP way will be pretty easy. A good example is that linked list. The easiest of like implementing a linked list will be using classes. Yeah.
Okay. Nice feedback. Anyone else? Anyone else with a question? Right, so let's do one more example. Okay, so we want to we want to have a constructor for laptops, for example. We want to have a constructor for laptops. Laptops have brands, they have colors, and a bunch of other similar things, right? So now, can anybody guide me on how to create a constructor function for a laptop? Well, how do we start? What is the first thing we need to do? Can anyone give it a try?
You need to start by defining the object and properties.
The function.
So what's the first thing that we need to do? Is it Catherine? Yeah, not sure.
Function laptops.
Okay, so function laptop.
Then we give it properties.
Okay.
Uppercase
So
L.
Use uppercase L because it's a constructor function. Next, so this.
Yeah.
Then what do we do here?
It's equal to brand. Then this dot color is equal to color.
Yeah, that's it. That's all we need. We just need those two properties. That's it. It's okay with those. What's the next property? What do we do next? How do we now use it? Look at your constructor function. Is there anything we are missing?
Are we supposed to define it in the bracket, the property?
Yeah.
The arguments like brand and color, you should have the parameters there.
Good. Because what happens is, right, so what is going to happen now is when you call that function, right, it's going to take this, whatever you're passing it down, and now assign that value to this dot brand. That's what happens. And then the color is going to be put here. Okay. Just think about any normal function, right? When you pass down those arguments, that's what it's doing. Okay. So, and then what's the next step? We now want to create a new laptop object. A HP, for example, HP laptop. How do you go about it?
Shall say
Have the
const
constructor.
HP.
Const HP equal to the next thing.
Is equal to new laptop. New laptop. Then we give it a brand and a color.
Okay, so HP silver, and let's console log that value. HP. Yes. So now we can create multiple objects using that laptop constructor. Is it making sense? Is it clear? Is it looking less intimidating?
Yes, it's clear. Though, Ian, I had a question. I see that in the person function, you had another function for speak. So at what point do we get to use such functions, like to have a function within the object?
It depends. Like, it depends on your implementation, because some objects don't need to have methods. Trying to think of an example. For example, if you had like it's difficult to think of one right now. Can anyone think of anything?
Let me give an example. Like assuming we had a constructor function that maybe creates the books in that book list.
Yeah.
You'd have maybe a method for creating, a method for updating, a method for deleting. Yeah, something like that.
Yeah, that actually makes sense. But most of the time it just depends on like what are you constructing, because there's things that don't need to have methods. There's things that don't need to have methods. So
Can I try a very simple example? I think this will simplify. If you are maybe creating a calculator function, and now you define the constructor function, and then maybe there's a function to add, another function to subtract. Those are methods that can be used within the calculator.
Yeah, that's a very good one. Yes, that's a very good one. If you had like a calculator that takes in two numbers, you know the two numbers are always going to, those are going to be properties that are always going to be there, right? They are not dynamic in any way. They're not doing anything. But now if you have an add function that takes in those two things, the first number and the second number, and then returns, for example, the sum of those two numbers. So that's a brilliant example, actually. I hope.
Okay, so when we are adding into, when we, for example, for the calculator, what kind of instances can we have for that object?
See, you can think of like if you have multiple calculators, because you can assume, like for example, think about your laptop, right? Let's VS Code is a perfect example, actually. You can create multiple windows, right? Now, if I was to come here, think about it at a high level, right? If I was to come here and open a new window, you can see, right? Now, this window is separate from this window, but they have similar properties. This one has a file, an edit, a selection, blah, blah, blah. Same with this one. We have a file, an edit, a selection, a view, blah, blah, blah. Now, the way it might be doing it internally is, right, we are using the same constructor to create the object, the VS Code object, right? but they're different.
Yeah.
Because let me just try to make it here. So const, let's create a function called this code. Okay, set that to a function, right? Then simply return this dot window to window. We have a window, we're passing down. Okay. Now, think about it this way. If you're the one who implemented your code, your VS Code, okay, the way you will isolate those two things, the way you isolate those two instances of the same process, because it's the same process, they're both VS Code windows, is you create a new instance of it every time you create a new window. So, ukifanya hivi, for example, this first window can be const window 1 is equal to new VS Code, then instantiate it, set it to true, right? And then you can have another one, const window 2 equals to VS Code false or true. Now, these two things are separate. You do whatever you want on this side, as you still do whatever you want on this side, because you may create two instances of the same thing, but they are isolated. So in the calculator example, let's assume you want to create multiple calculators. Let's say we want to make a calculator moja, you're using one calculator, I'm using another calculator, but all from the same process. We can create different instances of the same calc object. So that I have access to the add functionality, and you also have access to the add functionality. When I use add, you don't have to stop using add just because I am using it also, the add functionality, because they're separate. I don't know whether that makes sense.
Okay, so
Yeah.
it makes sense, but what I'm asking is that yes, we have a calculator, and within this calculator, we have different properties, add, subtract, and say divide, and each have functions. So for the new instances that we've created, say calculator 1, if we want to add, we shall be putting it as an argument in that instance, right? And then we'll give it values if we want to add and subtract at the same time.
Yes, you have to pass down the arguments. You have to pass down the arguments.
We pass the arguments with also the values in the.
Okay, so first num, second num, and this dot first num is equals to first num, this dot second num is equals to second num. Then we can now define our methods, right? So this dot add, right, is equals to a function. Then we want to return dot first num plus this dot second num, and then subtract function. Then we have return. Is this what you're asking? Get it?
Yeah, I just thought that the arguments will be add and subtract in that function. But I guess it's the numbers.
Yeah. Makes sense?
Yeah.
Okay. Right. Anybody else with a question or a comment? Sawa. Everybody's okay? We're coming up to an hour actually. Okay. I don't think we have enough time to talk about prototypes. I think that might confuse you guys. So I think for today, just try to consume whatever we've done today. Try to understand the whole process around like objects, constructors, how they are working, what is the point behind, why do I need a constructor, and then now how to use them. And then now tomorrow we will look at prototypes because they are also important. And we'll also look at classes. So classes were introduced in year 6, but we'll walk through them tomorrow. And then now, once we are done with those two, then we go into prototypal inheritance and stuff like that. But before we end, I think I can, we do have a bunch of built-in constructors. So for example, JS comes with a bunch of inbuilt constructors. So we have one for string values, we have one for objects, we have one for numbers. So let's look at strings, for example. Normally, the way you define your strings is okay. So that's how you define your normal primitive values. When we say primitive values, we simply mean they just do one thing. From the name, like primitive, just does one thing. Okay, so this string value only consumes strings. That's what it does. Doesn't do anything else. Now, we have another way to do it. We can now declare this string value as an object. The way you do that is const maiden 2. Same process. Anytime you want to use a constructor, you have to use the new keyword. Okay, so now if I come down here, I think it's already complaining. Okay, this is just VS Code complaining. It's not something you will use a lot, but it's also nice to know that it exists. It's not something we'll be using all the time. So now, if you look at maiden 2, you can see maiden 2 is as we have the string constructor. If I check the type of, this value, get an object. If I check the type of the first one, I check this type of a string. So you can see the difference. So for this one, we can add properties to it for maiden name 2. Because it's an object, we can do that. But this one is a primitive type. The first maiden name is a primitive type. It's a string primitive type. So you can't go ahead and add stuff like another last name property or a first name property. So these primitives, these constructors are available for almost all the data types that you use in JS. So arrays, you can have new arrays, you can have new booleans, new numbers, all of them. And they will now transform your primitives now into objects. Same with functions, but the syntax is a bit weird to even look at. But we do have like built-in constructors. But new, if you remove the new keyword, different now. It's now not using the constructor. It's now using the actual string primitive value. Because now you can see they're both strings. They're both of type string. But when you do have your new keyword, then it knows that you want to use it as a constructor. So now it's changed to object and string value. Okay. Anyone with a question, comment? Albert, any comment? Or Albert left. Nelson, anyone before we end? Okay. Joseph, do you have anything else to add?
You've done a good job explaining it.
Okay, all right. Fatma still here. Fred, are you okay? I know you're doing a lot of Python and low-level languages. Some of these concepts might look familiar.
Yeah, they're so familiar. I think I can even kind of transfer some of the things that I'm seeing here to understand classes. Classes and objects in Python, which we are currently doing. So yeah.
Okay. All right. So, okay. Ian, are you okay? Eunice, I normally like doing like a head count. Just
Yeah, I'm good. I'm good.
Yes,
okay.
I'm okay.
All right. Okay. Is Fatma still here? I know Fatma wamekuwa wakifanya. They've been doing OOP at Moringa.
Hi. Yeah, I'm
Hi.
here. But like,
Okay.
what we did wasn't what we're doing here with you. I mean, this is just day 2, and I feel like I understand so much more. Plus, it would have been better if we had like delved deep into OOP before we started React, because yeah, a lot of the concepts are.
Yeah, but you can see like how you can now transfer this knowledge into now a React.
Yeah, I can.
Yeah. Okay. I see Jeff left something in the comments. Yeah, that's true. That's why I said you don't normally see this a lot. I just mentioned it because it's good to know that it's there. But it's very rare that you'll actually use the new keyword to define your data types. It's very difficult for you to find yourself using the new keyword or built-in constructors. Initially, they used to be used a lot, but nowadays they're not used so much. Again, JavaScript is a weird language. You have to remember it was created in 10 days. So, and then the other thing is JavaScript is what is called a backward compatible language. Okay. So the minute you put something into the language, so to your question, Jeff, the creator of JS might have probably thought it was a good idea to have like primitive data types that way. Now the main problem is, yes, it's also weakly typed. And by the funny fact, the weakly typed thing was as a result of when they were doing testing for JavaScript initially, the very first few days, the initial testers for the language just asked the developer, the creator of JS, to make it weakly typed. That's all. That's why they actually did it that way. It wasn't like it was not something he wanted to do from the get-go, but because it was a new language and they were trying to market it as quickly as possible, he just agreed to do it. I think JS is also one of the very few languages that has a double equals and a triple equal sign. So when you want to compare two things, right? So for example, if I was to, we have these two values, right? I have the new string, which is set to Chris, and I have the Chris maiden name here, which is set to the primitive value. If I come down here and I try to compare the two, I come down here and I say, I don't want type of anymore. I simply want to check the two values, whether they are equal to each other. If I go into the console, I will get a true value. Okay. Now, if I use a triple equal sign, I will get a false value. See that weird behavior? It's because the double equals is just comparing the values, not the types, not the type of data. Because this first one is a string value. It's a data type of string. It's a primitive string. This other one is an object. But when you use double equals, it's not checking the type, it's checking the value. The values are the same. They both have Chris as the value. But now when you put triple equals, you now get false because now it's doing a deep comparison. It's comparing the types, not the values. So again, this is one of those weird behaviors in JS that came as a result of that, the way they did it so quickly when they were developing the language. It came with a bit of weird behaviors that you don't find in other languages. That's why you find some people who call themselves real engineers in quotes don't like JS because of all this weird behavior that you get from it. But it has a story to it. There was a reason as to why they did it that way. And then again, the language is backward compatible. Once you put something in it, you cannot remove it forever. It has to stay there. Okay. Yeah, type conversion. Yeah, that's true. Right. Okay, I think that was a very nice session. Stop presenting. So tomorrow we will continue with the same. So the minute tumemalizana na hii session, once we're done with the session, I'll push the code to GitHub. Again, you can just go over it. And then tomorrow now, we'll continue with the same thing. The reason I didn't want to do prototypes today is because I know for a fact it might be, you might get confused. It might be too much to handle in one session. So I normally like to split them into smaller pieces. So now tomorrow, because we know what this does, we've looked at constructors, we can now look in depth into objects and prototypes. Because if I look at my objects, right, if I come here and I, for example, come, for example, and log out one of the HP, for example, object, I open it up, you can see we have a prototype object here. So this is what we're going to be talking about tomorrow. What is this? Why is it needed? How do you use it? And why is it important? Because you can see we have two prototype objects. We have this one here. We have the constructor, which is now pointing to the laptop constructor, which we created. And then we have another prototype object. So we look at, so this has something to do with numbering, stuff to do with inheritance. Okay, so we will look at that tomorrow. Okay, so thank you guys for joining today's session. Come tomorrow again with the same tunayo momentum pia kesho. We finish up whatever is remaining. And then and then now on same to me, same as well for me, Ian. And then now on Thursday, we will actually build something with OOP. And that should now actually show us how to actually use it in your project. Then Friday we're supposed to, we'll set up the project we're supposed to do, the front-end mentor project on Friday. But on top of that, we look at design patterns because there are certain, we have talked about the DOM, Nelson, just a bit, not too much. Yeah, but we'll see how to, yeah. So we will look at design patterns because design patterns play a huge part when it comes to now using concepts like OOP. We have one called the factory pattern. As the name suggests, you're creating a factory of something. So you can already tell from what we've done at Aleo, constructor functions can be used for that pattern, but we will go more in depth in terms of how to use them, when to use them, how they look like on Friday now. But Thursday we'll do a project. And then on Friday, that project that we've done, we'll try to use one of the patterns that we discuss on Friday. Sounds like a plan?
Yeah.
Yes.
All right.
Thank you.
All right. So you're very welcome. So
Thanks,
see
Ian.
you guys tomorrow. You're very welcome. So I will see you guys tomorrow and enjoy the rest of your evening. Time for me to now watch Netflix.
Thank you.
All right.
Thank you.
All right. Bye-bye.
Good night.
Good night.